Hello learners. In the previous lecture, I have discussed about the regular expression and how we can use the regular expression to match the pattern in the text data set. So in this lecture, I'll be discussing about the pre-processing of the text data, which is a very important step whenever you are starting any of the analysis on the text data. So the pre-processing of the text data is done because of several reasons depending on the type and purpose of the text data. So some of the common pre-processing of the text data is highlighted in this slide. The first is the removal of the noise from the text data. Many times it has been seen that the raw text data contains some URLs and other irrelevant information that is not so important in the context of our analysis. So we need to remove all those kind of text from the raw data. Okay, then we remove the punctuation from the text data. Okay, so these punctuation like comma, semicolon, hyphen, etc. are just the connecting symbol which are dividing the sentences and the phrases. Okay, so and these connecting symbols are just for structuring the text for reading purpose, does not carry any of the semantic meaning. So we remove these punctuation from the text data. So then we do the lower casing of the text data. So the lower casing is done to map the similar word to in a same group. Okay, so say for example there is one word is like Mohit is in the lower case and another word is Mohit which is in uppercase. Okay, so these two Mohit conveying the same meaning, that there is a person whose name is Mohit, but one is written in lower case and another is written in the uppercase. Okay, so we need to map these two words in a same group, that okay, these two word, one is, though one is written in the lower case and another is written in the upper case, but they are the same word. Okay, so next we do remove the stop words. So stop words are the most occurring word in the text data, like a and the and etc. and all. After that we remove the numbers, like some numbers are there, some digits are there. So we remove those things from the text data. And in the final step we do stemming and lemmatization. So stemming and lemmatization are the two key technique in the analysis of the text data, which map the words to the base or the dictionary word. Okay, what exactly stemming is and what exactly lemmatization is, we'll discuss when I'll be discussing particularly stemming and lemmatization. So these are some of the things what we do in pre-processing. Again, I will mention that the pre-processing of the text data depends on the type of data and the purpose of your analysis. So in this lecture we will be taking up the text of scientific publication. So and we will be doing some of the pre-processing on this data. Okay, so let's move to our R studio, where we will be importing the data and then we will doing the pre-processing of that data. Okay, so before doing any of the analysis, the very first thing what we do, we need to know that what exactly our directory is and how we exactly check our directory using the function get working directory. So if I do like this, so it will give me that my directory is user del documents, and whatever the directory you are in whenever you are doing the analysis. And if you want to change the directory, like my current directory is document, but if I want to change it to download, so I can change it using the set working directory. Okay, so I have kept my data, this particular data, in the documents directory, so I don't have to give the whole path, I have to just mention the file name. So this is a data. So this is a dummy data which I am taking up for this analysis. So what this data is, this data is the 50 documents which are published in Journal of Cleaner Production. So we'll see it. So this is my data set, it's in documents, so I'm reading it and I am assigning to an object df.jcp. Okay, so this is my data set and my data set is imported. After reading the data, what next we will do, we will see what exactly that data is. So how we will do that, we will view it. So we will use the function view, and if I run it, so this is my data set is, it's a all scopus data which have all the details like authors and page count, citations, affiliation and all. But for this text mining thing, we are only focused on title and abstract. Okay, so we will be considering this title part and then our abstract part. Okay, So this is our abstract. So from our data set, we have lot many columns. So if we have to see what are the number of columns are there in our data set, what we will use, we'll use ncol, and we will give the name of our data set. So there are 34 columns are there, but we are focused only on the two columns. What are those two columns are? One is the title and another is abstract. Okay. So how to access the title and abstract? We'll use the dollar sign. So this is my data set, and if I write the dollar, it will automatically give me the name of the columns. So here I am taking the title, and another I will be taking the abstract. Okay. So if I see first title of my data set, so this is how I can check it. So this is the title of that particular paper, and then if I have to see the abstract, in the similar way I can check the abstract of our data set. Yes. Okay. So now we have a data set. We have a data set of 50 publication published in Journal of Cleaner Production. Now we have to do the pre-processing on this text data before going for the final analysis of topic modeling. Okay. So this title is in one column and then abstract is in another column. So what we will do, we'll combine it and make it as a single column, because we are considering both title and abstract for our analysis. So what we will do, we will just simply combine this thing. Okay. So for combining, we have a function in R which we call it as paste. Let us see how paste works first. So this is a paste function, and if you want to know about paste, so what we will do, we'll use the this question mark symbol, and if I run it, so basically this paste function concatenates the strings. Okay. So and how we have to call it, we have to call it in this way. The examples are also given. Okay. So let's take one example how this is connected. So let's say, for example, we have one text Mukesh Behra and another text Mohit Garg. So if I have to concatenate those two things. Okay. So how we will do, we will use this paste function, and then we will give the, this is a text 1 and this is a text 2, and combine these two string. Only thing is that separated by a comma. If I do like this, so my output is this. So my two strings are concatenated, they are joined together. Then if I have to like give extra space or something like that, I can assign here. And if you see here, the difference between these two joint string. Okay. So the first one is that only comma is there, but in the second output you see the comma and then space is also there. Okay. So in similar way, we can join our two strings of this title and abstract also. So we will combine these things. So this is our whole title data and this is our whole abstract data. So we'll use this function in this way, that this is my title and this is my abstract, and it should be separated by either we can give the full stop or comma, whatever like we can give. So this is my function paste, which I am calling it here, and after pasting it, what I am doing, I am also making it as a data frame. I am making one more column of that data frame. Okay. So now I will run this and I'll assign to this object called dfjcptiab. So if you see, I have just given the name related to what exactly my data set is. Okay. So whenever you are creating an object and you are doing analysis, always try to give some kind of words which are related to your task. Okay. So if we see this particular object is showing that this is a data frame, then JCP is the short form of Journal of Cleaner Production, and what I am saying is TI is title and AB is for abstract. Okay. You can give any other name, like you can just assign TI or A also. Okay. TA. Okay. So in this way also you can do. So but I am going in this way. So if I run this, so my data frame is created. So what exactly we have done here is, so this is my title data is there. Okay. And this is my abstract data, and then I have combined it, and it should be separated by dot. and after combining it, I am making it as a single column of a data frame. Okay, like say for example, if I do like this, one, one. Okay, so what exactly it is doing? It is combining title and abstract, and if I run this, so this is my title, drivers for and barriers to low energy buildings in Sweden, and from here my abstract is there. Okay, so if I have to see my title, so this is my title, and if I have to see the first abstract, and this is my abstract. Okay, that is what exactly we have taken up the whole old 50 titles and all 50 abstract, and then we have combined it, and then we have made a one single column. Okay, so now our data set is in this particular object. Okay, so from here we can see the column names. So if you see here, this particular column name, it's showing that what exactly we have done here. We have pasted the df jcp title and df jcp abstract. So we have combined the both title and abstract, and then we have separated by this dot. Okay, so what data frame does? So data frame takes it as the column name and assign to that particular data. Okay, but this particular column name is too big. So what we will do, we will make it as a short column name. We'll change the column name of this particular data frame. And how we will change the column name of that data frame? So we will just simply use the call names function, and this is my data frame, and here I am just giving the text. Okay, so if I do like this, and now if I see df jcp dollar text is there. Okay, so now my column names are not too big, so it is text. Okay. So this is just a optional way of doing, but if you don't want to change the column name and if you want to go with this column name, it's absolutely okay. It won't make any differences in analysis. Okay, so just to do the things easier, we have changed this column name. Okay, so if I do here, so this is my data set, and if I see my first title and abstract of the publication, so this is the thing is okay. So this is my title, and then it's starting from here abstract. Okay, now we will do start our the pre-processing on this text data. So the very first thing what we will do, we will check whether any irrelevant information is there. Okay, so what we will do, we'll see the data. So if we see here the first, and just give a reading to this particular data, first title and abstract. Then if we see again here, so in these two text you will see that this in the end this is coming. Okay, so in the first title and abstract, this was the common thing, it is coming in the end of the abstract, and then in the second one it is coming this copyright 2015 elsewhere limited all right reserves. Okay, so we don't require this thing for our analysis. It doesn't make any sense if we include these kind of text in for our analysis of topic modeling on this particular text data. So we will remove it, and how we will remove it? We will use the regex. We will make some regular expression to match this pattern, and we will remove all the this publisher by elsewhere or all right reserve from the text data. Okay, so before going ahead, let us first see, is there any other way this particular text is written? Okay, because if you see here in our first abstract, it is written like copyright 2014 published by elsewhere limited. Okay, but in the second case it was written 2015 elsewhere limited all right reserves. There is no that published word is there. Okay, so let us see if third is also like that. So in third we have copyright 2015 elsewhere limited. We don't have that all rights are reserved. Okay, what we have in this second one. Okay, and now we will see for the fourth one also. So here we have, okay. So from this we get to know about that there is something like the same text is written in different way. So we have to take all these three patterns and then we have to make the regular expression in such a way that whatever the way this elsewhere thing is written in that particular abstract, we should remove it. Okay. So if you see here, so this was the string in our one of the abstract, then this was the string and then this was the string. Okay. So all these string have common is that one is copyright. So our regular expression must include this. Okay. So that is one thing is clear to us. Then we have another thing is that in all the three string there is a pattern of like year is given and year is in 4 digit. Okay. So 2014, 2015 and 2015. Okay. So these are of 4 digit. So we want this symbol and after that what we want 4 digit. Okay. So this is pattern is there. After that what we have two instances where elsewhere limited is there and in another instance it start with published by. Okay. So what we can do is we have to make regex in such a way that it should match this also, this also, this also. Okay. So if you see here, I have made already the regular expression for matching these strings. So what I am saying here is that, so this is C, so it is matched to this one. Then I am saying that digit 4. Okay, we have already discussed what exactly this is. This showing that digit 4 digit. So whatever the occurrence of 4 digit, so 4 digit is there. Then I am saying then published. Okay, so it matched to published also. Then I am saying that this small s plus what exactly it is saying? It is saying that one or more white space. So this particular white space is matched by this s plus, small s plus. Okay. Then I am saying by, so it matched to by. Then again I am using this one or more white space. So this is the white space. Then elsewhere is there, elsewhere matched, and then one or more white space. So this is white space, and then LTD. One of my regular expression is done, and then we have like for second one, we can do like this, like so this thing is common in all the three patterns. But here, if we want like here, we want elsewhere limited, but in this one we want elsewhere limited, all right reserve also. Okay. So these are the three pattern we have identified and we have defined the three rejects to match the these pattern. Okay. So if you see here, so this is my one regular expression, this is my another regular expression to match this one. So this one is for this one, then this is for matching 2, and this is to match this 3 number. Okay. Now we will move to R and then we will see whether it is matching or not. So we have already discussed about this particular function grep which help us in matching the pattern, and so to remove these things from the text we will be using another function which known as the G sub. Okay. So what G sub is, if we have to see G sub, we'll use the question mark and we'll see what exactly G sub is. So it's a pattern matching and replacement. Okay. Like what we used to do is like control H, which exactly find and replace. Okay. The same thing is done in here. Okay. So this is my first pattern. So we have defined there. So if we see here, let us use this graph function. Let us see where exactly our particular pattern is there. So if we see, okay, there is a one occurrence of this particular pattern. if we see here this one, we have these like 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay. So we have 31 abstract data where it is matching this, and then if we check for this, okay, so it exactly 49. Okay, 49 these abstract are there where we are matching this elsewhere LTD. Okay, so this elsewhere is LTD is matching this one also. Okay, so if we count, so for this particular pattern we have 18, and for this we have 31 abstract, and for this we have only one. Okay, so that's our data set is, we have only 50 abstract. So out of those 50 abstract we have this one abstract, then we have 18 abstract for this, and we have 31 abstract for this pattern. Okay, so we will remove these things from our text data. We'll make the pattern. So there are like two way of removing this particular string from that text data. Okay, how? So one is way that we will remove first from the first where the published by elsewhere limited is there. Then we'll go ahead where the 18 those patterns were matched, and then we'll go to the 31. Okay, but this is like a too many steps process will be there. But we can call all these pattern in a single way, and then we can like remove all the occurrence of any of the patterns from the text data. How we will do that? Here we have another operator known as pipe. So what pipe does? Pipe just like a we have a boolean or operator. So it is like we are giving all the three rejects, and wherever you find any of the rejects, you just match it and replace that particular thing with whatever the things we want to replace it. Okay, so we are defining, this is our pattern is there. So this is our first pattern. Then we had put the pipe, and then again we have another pattern, and then we have put the pipe here, and then we have here this, again the pattern is there. Okay, so if you have noticed that in this particular thing I haven't used the question mark before pipe, but here I have used the question mark twice. Once is here and once is at this part. Okay, so if you have seen that there may be the possibility that after LTD there is a no chance of this some may have the period sign and some may not have the period symbol. Okay, so this question mark exactly does that. Okay, if there is no occurrence, you consider this, but if there is a occurrence of this period, you consider that and remove that particular string from the data. Okay, so this is my pattern is there, and now what I will do, I will consider the g sub function. So as soon as you put the cursor here, it will show what all things you have to give. So you have to give the pattern, then you have to give the replacement. Okay, what exactly you wanted, and x is the data where exactly what the data you are considering. Okay, so for my this particular pre-processing, I have the pattern my pet. So I am giving the my pet as a pattern. Then replacement, I'm just giving an blank. Okay, so I if I want to put it like a comma or anything or plus or anything, I can put it, but for the time being I am just removing this and replacing with a blank, and then this is my data. Okay, so if I do like this, and now if I see this, so that that thing is removed, that published by elsewhere. If I see, okay, so in this first abstract, this copyright 2014 published by elsewhere limited was there, but if you see in this removed uh, abstract, we have removed it. Okay, so we have removed the first string from our text data, which is like unnecessary for the kind of analysis we are doing. Similar way, if we can check for the second one also, like if we check second, so there is no that elsewhere and copyright symbol is there. I can check for third also. Okay, and the similar way we can check for another abstract also, that whether that elsewhere is there or not. Okay, so our first pre-processing of the text is done. So many times we have some other strings like a URL or email ID in the abstract. Okay, so we can remove that also. So let us check, do we really have these URL or emails or in our abstract? Okay, so how we will do? So this is the pattern. So what exactly this pattern is, that any occurrence of HTTP, because the URL can start with HTTP or HTTPS or FTP or maybe the www dot. So I am matching if there is any such occurrences is there in my data set, integer 0. So what exactly integer 0 means is that there is no such occurrence of any of these URLs are there in that particular abstract. Okay, so we don't have to call this gsub function to remove this URL, because we don't have the URL in our abstract text data. Okay, then we can similar way we can check for email also. Like for the time being, I'm taking email as at the rate, but wherever at the rate symbol is there between the two phrases or words, it will be an email ID. So we'll check whether we have this kind of thing in our data set. So again, it is showing that there is a integer 0. That means there is no such pattern of email in the abstract. Okay, so we don't need to run this. If we have the occurrence of any of the email and URL, we have to run either this or maybe this one. Okay, for URL. But though we don't have these things, so we are not running these URL removal and email remover. Now the second things in the pre-processing is the lower casing of the character. Okay, so lower casing is that there may be a possibility that the same word which convey the same meaning may be written in different form of words. Okay, say for example, you take this Mohit, this Mohit, and this Mohit, and this Mohit. Okay, so these all four words are conveying the same meaning, that this there is a person whose name is Mohit. Okay, so there is a thing which is named as Mohit. Okay, but these are written in different way. So here there is a one capital letter is there, then all lowercase is there, then all uppercase is there, and then we have a mix lowercase and uppercase. Okay, so we need to standardize these words to a single kind of a form. So what we will do, we'll put a lower casing. So what exactly lower casing? After lower casing, it will be like Mohit. It is already Mohit, so it will remain Mohit. In this way, it Mohit, and okay. So when you count the number of words in like this way, we have already seen the table function. We'll see in our how exactly, but whenever we will be doing the tabling of this, the output will be like Mohit. There is a occurrence of 1, then Mohit. There is occurrence of 1, then we have Mohit. Occurrence of 1, and then Mohit. Occurrence of, okay. But when we run this table function on this one, it will give me the output Mohit 4. Okay, so that is why the lower casing of the text data is a necessary step in the pre-processing of the text data. Okay, we have this as a object where we have these different way of Mohit. So if I run it, and now if I table it, just to check the occurrence of each word, so you see that Mohit, there is 1. Though these all 6 Mohit are the same thing, but it has been counted at 111 to each one. Okay. So now what could be the possible function name to transform the lower casing of the words? Okay. So just you pause the video here and just think what could be the possible function name. Okay. So the function name to change the lower casing of these words are to lower. Okay. So this is a function which transform these all kind of words to a lower cases. is a function. We can check it by using the question mark sign before this, and what exactly it does. So it change the cases. Okay, so there is another function called to upper which change the uppercase. So we'll see both of them. Also, if you write any function name, like if you write to lower, it will automatically show you that to lower is a function which is a function inside the base package. Okay, if you have like different function, it will be of different package. Okay, say for example, if we use mean. Okay, so it is automatically showing you that mean is a function in base package. Okay, if we see here there is another function called mean cl bot, but this is a part of ggplot2 package. Okay, so if you don't have ggplot2 package in your system, you won't able to see this function. Okay, so that is again we need to know that what are the function we are using, what exactly the package where it is. Okay, so there is this is another thing we need to remember is that whenever we are using any of the function. Okay, so from where this function is coming. Okay, what exactly that package is. Okay, for base package we don't have to call each time library because that thing. Okay, but we if we have another package like ggplot2 and other thing, so bibliometric, so we have to call those libraries using the function library, and then we can able to use those functions. Okay, so if I do like this, and now if I do table, it's showing there is a Mohit which is occurred by 6 time. Okay, in the similar way we can do the to upper also. So to upper, and now if I do like this. Okay, so there is a word called Mohit which is in uppercase, which is occurred 6 times. Okay, so this is the way you can do this casing of the text. So here we are changing the text to a lower casing. So how we will do? This is our data set. So whenever you are doing analysis step by step, you must remember that what object you have created. Okay, so now my process data from the step 1 where we have removed this elsewhere is this rampart. Okay, it's not that df jcp tiab. Okay, dollar text, because we have made the first pre-processing and now our data is this. So if you see here, after pre-processing of step 1 we have this data. Okay, we don't have to use this. Okay, because this is the pre-processed data which has the elsewhere and all those things. Okay, but this is the object where we have the data which is after removing these elsewhere or all right results. Okay, so we'll call our object. Here we have data is from step 1 where we have pre-processed it. Now I will assign this lower casing of this particular data set to a new object which I named is at df lower. Okay, so if you see this particular data, so this was my earlier data after step 1 where we have removed elsewhere. So if you see here, we have different words like even is there, then moreover is there, then if you see here, like from is there, this from is there, and then we have from here also. Okay, so in one all the letters are in the lower case, and whereas in another from we have the first letter as a uppercase. Okay, so if we see output of this, now if you see this abstract, you will see there is no uppercase is there, all this from is there, and then if you see below this from is there. Okay, so both are in the lower case. Okay, so this is how we can change the casing of our text data. So until now we have done the two step of pre-processing. So one is that we have removed the unwanted text like published by elsewhere or all right reserved, and in another step we have done the lower casing of the text data. Okay, now we will move to the third part of the pre-processing is the punctuation removal. Okay, so what punctuation are? So punctuation like period, full stop, comma, colon, semicolon, hyphen, etc. are the connecting symbol, and that generally used in dividing the sentences and the phrases. And punctuation are only used for structuring the text for reading purpose and does not carry the semantic meaning. So we'll remove all those punctuation. So let us take the example of here that this there is a punctuation marks has been assigned to each of the word. So we have Mohit, comma, then we have Mohit, this, then we have Mohit semicolon. So we do like this. So now our object is this. To remove the punctuation, we need to have a package. What that package is? So there are different kind of packages there, but whenever we are doing this text mining, we have a separate package called as TM. So TM has a function called remove punctuation. If you don't have installed the package TM in your machine, it will be displayed here that package TM and other required but not installed. But if it is installed, so we have to call that library. So we'll call it. So our TM package is called. Now there is like function is there which is used for removing the punctuation. Okay. So what exactly that function name is? So what we have to do? We have to remove the punctuation. So the function name is also remove punctuation. Okay. So if I go here, as soon as I write here remove, it will also show remove punctuation. And this function remove punctuation is in the TM package. Okay. So this you have to remember that okay, this is the function which is exactly the part of TM package. Because why it is important? Because whenever you are calling it any function and you haven't installed or you have not called that library, okay, so in that way it is very important to know. And if I have to see how to use this remove punctuation, we'll use this question mark for seeking the help. So if I do like this, and you'll see here the arguments, the types of argument we have to give, and the example how we have to call it. So our data is this A, already created this object. So if I simply run this, okay, so all punctuation are removed. So the same thing we will be doing on the data set what we have received after doing the pre-processing at the step 2. So what exactly the object name what we have got it from after step 2 is DF lower. Now it's not rampat. Okay, rampat was a data set what we have got from after pre-processing at the step 1. Okay, now I am calling this and assigning to a another object DF pun1. Okay, now my punctuations are removed, and now if I see it, okay, my punctuation have been removed. So if you see here, all dots and other things have been removed. But here one thing is happened is that when we have like sometimes we have these dashes between the words. Okay, so it has also removed the dashes particular between the words. Okay, so if you see here, this low energy in the earlier our data set, this was a dash was there. Okay, so if we see here our data set, maybe rem df lower. So if you see here, we have dash here life cycle, then we have dash here also, then we have dash is energy efficient, energy efficient is there, then we have this in low energy. Okay, if you see here this low energy, it's a one word is there now, but we want like after removing the punctuation in such a case there it will be two words, low and energy. So we don't want these two words as a like a single word, but we want as a two separate words. Okay, so how we will do? We will use the our earlier function g sub. Okay, so in that case our g sub is there, and this is our punctuation rejects. So now what I am doing, I am saying that in g sub, wherever you see the punctuation, okay, you just replace it by a extra space. Okay, so I am here putting the extra space. Okay, and this is my data set. So if I do like this, and now if I see the output of my data set, so you see here that, so it's low energy. Now the dashes is removed, but extra space has been added between the two words. So that is why for this removing the punctuation, it's a like better way to go in this way. Sometimes we have different words written separated by dashes and all. So in that way we can do a effective analysis. Okay, you can use the remove punctuation, and there is like another kind of argument is there which you can specify is that preserve intraword dashes. Okay, so it has like if you put it true, and if you do like this, so it will remove the punctuation wherever punctuation marks are there, but it will preserve these dashes. So life cycle, energy efficient, so this is there, the dash is there. Then we have low energy, dash is there, these dashes are preserved. Okay, so what exactly this it means, that you do the remove punctuation operations on this data set, but preserve the dashes between the words. Okay, so by default it is always false. Okay, but you can call it like in this way to have those dashes between the words. Okay, or you can use the earlier gsub function to remove the dashes and replace it by a space or any other symbol you want it there. Okay, till now we have done the three step in our pre-processing. So the first step what we have done, we have removed those elsewhere strings. In the second way, we have changed the lower casing of the our text data, and in the third step what we have done, we have removed the punctuation. Now we will move to a next step in our pre-processing, which is a stop words. So what exactly stop words are? Stop words are the generally the most occurring word in the our text data set. Okay, like a, the, is, all those words are generally called as the stop words, so which occur frequently in the text data set but have only a little semantic meaning. Okay, so to do an effective analysis, we remove all such stop words so that we can focus on the most informative words in our text data set. Okay, so we will see how to remove the stop words for our data set in R. So let's do that. So like as I discussed about, there is a function for remove punctuation. Okay, then in the similar way there is something called stop word. So we need to see what exactly is this stop word is. So we'll put the question mark here and we'll see. So like in TM package we have stop words. So it's like what exactly it is showing, that stop word kind of English language. Okay, so we can call it as in this way, stop words kind. If I run it, so these are the list of stop words. Okay, so what those stop words are, like I, me, my, myself, we, our, ours, yours, and these many stop words are there. Okay, but we won't be using this function. What we will be doing is we will be using the uh, function called remove words, and inside the removed words we'll call it as stop words. And what are the stop words we will be using? We'll be using the stop words given by the smart information retrieval system. Okay, so this smart information retrieval system is by the Cornell University, and we will be using those set of words to remove the stop words from our text data set. Okay, our data set after third step was df1. It is neither rampant or df lower, so our data set is df1, and this is my function remove words. So I am giving remove words, this is my data set, and stop words smart. Okay, so if I have to see what all those smart stop words are, I can simply check it. So if you see there, these are the number of stop words are there. Okay, this stop word smart has much higher list of stop words compared to the just simply if we are running this particular thing. Okay, if we are running this particular thing. Okay, so that is why we are using the smart stop word list. So if I run this, okay, now if we just see the data, this was our data after lowering the case. This one is after removing the punctuation. Now if you see here that this in is and all, now if I see here df stop, you see that all those stop words are removed. Okay, that is why this extra spaces you can see here. Okay, so you can define your own stop words related to your study, and then you can remove from the text data set. Okay, so like these authors have identified these many stop words for doing the topic modeling. Okay, so you can define your own stop words and then you can remove it. Okay, so how you have to do it? You have to make a list of stop words, and instead of stop word smart, you have to give the this that object which is storing your all those defined stop words. Okay, in similar way, you can remove these stop words related to your study from the text data set. And I request you that please define some of the stop words related to your study and try to remove some of those stop words from the text data set, whatever you have, and do let us know in the discussion forum that you have identified these many words as a stop words in your particular text data example. Okay, so if you see here, after removing the stop words, there is some extra space is there. Okay, so we can remove this extra space. So to remove the extra space from the text data, we have this function called strip white space. So it is removing the white space wherever it is available in the text data set. And if we have to check what exactly that package is where this strip white step is there. So strip white space is a function in the TM package. Okay, it's showing here. Okay, and we can check the help also for this. So if we see here, it is showing that strip white space from a text document. And how we have to call? We have to just call this function, and we have to give the x means the data set. We have what we have. Okay, so here we have the df stop. So I am just calling df stop and assigning to again to df stop. Okay, so what I am doing here is I am just cleaning up all the white space from my earlier data set what I have got it from the removing the stop words. Okay, so if I do like this, and now if I see my first abstract, you see here like extra white space has been removed. So if you see here, extra white spaces were there, but now the extra white space have been removed. Okay, the another step of pre-processing is that removal of number. So but like it depends on kind of analysis you are doing. So sometimes like you want to remove the numbers, and sometimes we may not consider to remove the numbers. So it totally depends. So if you want to remove the numbers, so how we will do? In the same way, the way we have removed the words. So we have this function called remove numbers. So if I call it like this, so my numbers will be removed. Okay, whatever number like 1 2 3 4 any numbers are there. Okay, so it can be removed. Okay, let us now call it as df rem num, and okay, so if I do like this, numbers will be removed. Okay, so now after this we have a step called doing either lemmatization or stemming. So what stemming and lemmatization are? So stemming and lemmatization both are the two important technique to transform words to their base or the root form. So in stemming there is a generally the suffix are removed, but in lemmatization the words are mapped to the dictionary word. Okay, then stemming sometimes generate the non-valid words, while lemmatization generate the dictionary correct word. Okay, so let us understand this with an example. So if you are doing the stemming for running, okay, so the output will be run. Okay, and if you are doing the stemming, if you are doing running, so if you are doing lemmatization on running, it will be run. Okay, but in that case, whenever you like do stemming on houses, so if you are doing stemming, it will take all this part. Okay, so now the word will be this house. Okay, but whenever you will be doing lemmatization on this, it will be mapped to house. Okay, so sometimes the stemming give you the valid word, but sometimes it may not give you the valid word. So this is the difference between the stemming and lemmatization, and it again totally depends on the study and the kind of analysis you are doing, whether you want to do stemming and or maybe this lemmatization. Okay, so but the lemmatization is like considered as the preferred practice because it mapped to the dictionary correct word. Okay, so there are some lemmas are there, and it mapped the word based on those lemmas. Okay, but lemmatization is a kind of like computational expensive effort. Like when you have a big data set, it takes a little more computation compared to stemming. Okay, so let us understand this with an example in R. Okay, so take this example where I have a string called I cooking biryani, which cooked, but I ran away from home when running run better. Okay, so this is my text. Okay, now for this again we need a package, and for that we are using the package called TextStem. So if you haven't installed, first you install the package. And how you will install the package? You going to this interface, tools, install package, or calling the command. Okay, so either way you can install the package. So after installing, we'll call this package. For lemmatization, we have this function called lemmatize strings. Okay, and we can see how exactly we can use lemmatized strings using the question mark. So here we have to like this is my data is there, and then dictionary I have to mention what dictionary that has lemma is there. So just I'll call it this. So if you see, my string was I cooking biryani. So I cooking biryani, which cooked, but I ran away from home when running run better. Okay, so cooking becomes cook, then cook, then also this ran becomes run, then again running run is become run, and better becomes good. Okay, but as soon as we will do the stemming of this particular data, let us see what it becomes. Okay, so this is okay, I is okay, cook is okay, which is okay, this cook is also, this is also okay, this is also okay. But you see here we have ran away, so it has ran the same word. Okay, so after stemming the word becomes same, ran only, and away become the y is removed and I has been inserted. Okay, and the similar way if you see here, better remains better only. So that is why generally it remove the suffixes, okay, within the word. But lemmatization just map the words to the dictionary words. Okay, so here I am considering that I am doing the lemmatization. So this is my data set. So this was my data set after the stop words removal, but I have removed number also. So this is my data set. Now I will do like this. So if I see the output after running the lemmatization strings, you see. Okay, so if I see my earlier data set, identified, promising, these were the words were there. So these words were mapped to identify, promise. Okay, so this is what lemmatized does with the text data. Okay, so that is why we have done the lemmatization of our text data. But if you want to do the stemming, you can do the stemming also. So let us see if like this was my data, and if I do like this df stem, now if I see, okay, so the large become LARG. Then if you see companies, ES is have been removed. Then in identified, ED is removed, promise, E is removed. So we are not taking up the stemming in this analysis. We are considering the lemmatization. Okay, but if you want to check it with the stemming, you can do with stemming also. Okay. So this is all about the pre-processing of our text data. So what we have done at very first step, we have removed the elsewhere. In the end of the abstract, we have the elsewhere and we have removed it. In the second step, we have done the lower casing of the our data set, because like some of the words may be written in different way. Then we have removed the punctuation, and after removing the punctuation we have removed the stop words, so that some of the common words can be removed. And after removing the stop words, we have also discussed that we can make our own stop word list also, and calling the remove word function, we can remove those stop words also. Then we have removed the numbers. We have removed numbers, like different numbers can be there in the text data set, so we have removed it. And in the last step we have discussed about that either we can do lemmatization or stemming, and we have considered the lemmatization, how lemmatization mapped to the dictionary word, and stemming just remove the suffixes. Okay, whatever the text processing we have done step by step. Okay, so we have first removed one thing, then we have removed one thing, and then we have moved to another part. Okay, but like whenever we have to do lot many text analysis on a regular basis, so what we can do is here, so we can make one kind of function, we can combine all these operations in a single function, and then we can create our own function. And those function can be called whenever we are doing the analysis at some other time. Okay, so how we will create the function? So to create a function, I'll just request you that you pause the video here, and just based on this much, like what are the steps we have followed, you create your own functions, and then see whether you have created the right function. Okay, so to create the function, we'll call this our function name. So this is our function name. So I'm giving it like week 9 clean lm, because I'm using lemmatization, and I'm using this function x. So why I'm using x? Because it's a single argument. Okay, so my data is in only a single argument. I'm passing it to single argument. We have seen the different kind of functions. So either the function where no argument is there, we have created the function called Mukesh, where no argument was required. Then we have seen the function where two argument is required, like add num. Okay, but this kind of like analysis, we need to create one argument function where we will supply the text data, and then it will pre-process the data. Okay, so if you see here in this function, we haven't used these two operations, because we don't have any of the URLs or emails in our data set. But if your data set have URL and email, so then you have to use these two operations also. Also, if you remember that when I was talking about function, if we just simply call these operation one by one, the output will be whatever in the last. Okay, so to get the output after each operation, we have to assign it. So here if you do like this, okay, and if you do not use this x here and this one, so the output will be whatever the last operation is. Okay, so in the better way, what we have to do is, like, we have done this. Okay, and we are assigning to that object. Okay, so whatever like my text data is there, so first thing it will be removed the URL, then the email it will be removed, then that string elsewhere. So after removing the this string, we will be doing the lower casing of our data set. After lower casing, we will remove the punctuation. So we will not use the remove punctuation because we want to have those two words low energy as two separate words, rather a combined word. So we are using in this way. Then we are using the stop word smart list for removing the stop words. So we'll call it like this way. Then we'll remove the white space because stop words removal brings some white space in the text dataset. So we'll strip that white space, and after that we'll remove the numbers, and in the finally we'll do the lemmatization of strings. Okay, so whatever the text string we have, we will lemmatize it. Okay, and finally after doing all those things, we'll return it x. Okay, so whatever my data, final data is there, it will be returned. Okay, so I'll just create this function. So my function is created. Now if you want to use instead of lemmatization, you want to have stemming. So here the rest things are same. You can, instead of lemmatize, you can use the stemming. Okay, so I am using this one. Now we don't have to go step by step all those things. My function is created, rest thing. So this is my data set, and this is my function. So what I'll call it here is that this all those pre-processing of our text data should be done on this particular thing. Okay, so if I run this, now I will see here. Okay, so it start from driver for and barrier to low energy buildings in Sweden. So this was our title, but after cleaning it, we have this one. Okay, so now our title becomes driver barrier low energy building Sweden. Okay, because other things have been removed. So this is our cleaned data set. Okay, whatever the analysis we will be doing, we will be doing on this clean data set. Okay, so what we have done until now is, if you see, this was our title, then we have this whole abstract is there, and this if you see, this was the line what we have removed very first thing. Then we have this lower casing, like this from was there, and then the another from, where it is, so another from is this. Okay, so we mapped these to a lower casing, and after that we removed the punctuation, all those punctuation we have removed. And while removing the punctuation, what we have done, we have just simply maintained these dashes. Okay, so wherever the dashes are there, we have put the white space. So we have put the white space here, then here also, then here also. Okay, then after that we have removed the numbers. In this particular thing we don't have numbers, and we have also removed the stop words. So these stop words, like these, all those stop words have been removed. Then and finally we have done the lemmatization. So this was the identified promising companies, these have been mapped to the root dictionary word. Okay, so this was our raw data set. Now our, after doing the pre-processing, we have this data set. Okay, so our whole data set is in the lower case. So lower casing is done. Then we have removed the punctuation also. While removing the punctuation, we have maintained that low energy, or this one energy efficient. The dashes here, earlier dashes were there, but now those dashes have been removed, and we have this white space. After this, we have removed stop words. So we have removed the stop words. So the common words have been removed, and then removing the stop words, we have removed the extra white space. There is no extra white space is there between the words. And we have also removed the numbers. This abstract doesn't have numbers, so we have removed the numbers, and also the finally we have done the lemmatization. Okay, where lemmatization? So this was company identify promise. Okay, earlier this was identified promising. So this is all about the pre-processing of the text data. I'll be sharing this all code in on our GitHub repository, where you can use this, and then you can do this pre-processing on a text data set. Okay, we will also provide you a some sample data set where you can just give a practice, and then you can have your this text pre-processing on your own data set. Okay, so in the next lecture I'll be talking about the topic modeling, how we have to do the topic modeling on this pre-processed data set, and what are like how to interpret those topics and all. Okay, so see you in the next lecture. Thank you.